So that is neutrophil. If you see an eosinophil, it is also granulocyte. Nucleus is bilobed, 2 lobes. And now the granules. Remember, basophil takes what kind of stain? Acidic or basic? What do you think? From its name. Basic. Makes sense? Basophils. Philia means attraction. You know that. Philia, right? So the granules will take basic stain. Philia. Basophil. So we will look. The granules will look purple bluish. So this is basil. Another granulocyte is called what? Anybody? Eosinophil. This is also bilobe, right? So it is difficult because both basophil and eosinophil are bilobe, right? But the granules of eosinophil will take acidic stain, red, so, or orange color, So now you see, you can separate them by stain, right? By dye or color. So these 3 are granulocytes, all have granules. Is it clear? But these granules are not very visible because they take both stains. Now, lymphocyte. Lymphocyte is easy to identify. Large, round nucleus. So, very thin rim of cytoplasm around the nucleus. This is the nucleus, okay? So this is lymphocyte. And no granules because agranulocyte. And monocyte is also easy because it is much bigger than other cells and has kidney-shaped nucleus. So this is monocyte, okay? No granules in the cytoplasm. No granules in the cytoplasm. So these are 5 different types of white blood cells, okay? How they look like. Neutrophils are very phagocytic. That means they can engulf very powerfully. Eosinophils, just know that eosinophils are sensitive to allergic reaction. Sensitive to what? Allergic reactions. So the number of eosinophil increases when allergic reaction occurs in the body. The number of eosinophil increases. They respond to allergy. By increasing the number. Basophils. Just know that basophils produce 2 important chemicals. One is called heparin and another is called histamine. Make sense? So this is important about basophil. Produce what? 2 important chemicals, heparin and histamine. Heparin is an anticoagulant. That means prevents coagulation, blood clot. Is it clear? Anticoagulant. Prevents what? Blood clot formation, which is very good, right? Otherwise blood will clot inside the body. Histamine causes inflammation. Histamine causes what? Inflammation. So these are the 2 chemicals produced inside the basophil. Here you see the granulocytes lymphocytes. Lymphocytes could be two types, T lymphocytes and B lymphocytes. Okay? And both are the parts of your immune system. Immune system. T lymphocytes do, just know that T lymphocytes do phagocytosis, and B lymphocytes produce antibody. Okay, so that's all about lymphocytes. T and B types and their functions. Okay, now let's move forward. Monocytes. Kidney-shaped nuclei, and the largest in size, I have already mentioned those two, so just know they do, of course, phagocytosis. All white blood cells do phagocytosis. Another important thing about monocyte, you see, much bigger than other cells, and kidney-shaped nucleus. Another thing, write it down, that monocytes can get out from the blood by diapedesis, and monocytes are converted to tissue macrophages. Okay, so tissue macrophages. Okay, so that's about monocyte. Leukopoiesis. Leukocytes are white blood cells, you know that, and poiesis means production, right? So leukopoiesis is the production of white blood cells. Erythropoiesis is what? Production of red blood cells. Leukopoiesis, production of white blood cells. Okay, and a number of factors or chemicals stimulate the white blood cell production. One is called interleukins. There are different types of interleukins. Okay, IL-1, 2, 3, 4. Interleukins stimulate the production of leukocytes. Another is called colony stimulating factor, or CSF. That also stimulates the production of white blood cells. All blood cells come from the stem cell, I have mentioned in last class, and that is called hemocytoblast. Okay, so all blood cells come from same stem cell, right? Called hemocytoblast. If you see the top, that is the stem cell. And you see, from that stem cell, you get all types of white blood cells. Okay, neutrophil, eosinophil, basophil, lymphocyte. And in last class, I have also mentioned that you get red blood cells from there, and you also get platelets from there. So basically, one sentence, all blood cells come from what? Hemocytoblast, which is the stem cell. Okay. Now, if you need, your body needs more white blood cells, then hemocytoblast, this is the stem cell, hemocytoblast. Okay, will produce another stem cell that is going to produce white blood cells. Is it clear? If you need red blood cells, produce more red blood cells, hemocytoblast will produce a different type of stem cell. And this will produce red blood cells. Okay? If your body needs platelets, it will produce another daughter cell, which is also stem cell. All these are daughter cells, stem cells, that will produce platelets. Okay, make sense? So, this is the early stem cell, right? That can produce any type of daughter cells. But now you see one thing, once this differentiation happens. This is called differentiation. Which direction this one is going, right? So once it produces this stem cell, this will only produce what? It will never produce red blood cells. Makes sense? So differentiation has already occurred. Once it will produce this one, it will produce only red blood cells. Okay, so that is called differentiation. Okay. Differentiation of stem cells. Okay, leukocyte disorders. You remember I said that normal count is 4,000 to what? 11,000, right? So if the number of white blood cell goes above 11, that is called leukocytosis. That means slightly above the upper range, right? Slightly above the normal range. That is called leukocytosis. You know, leukocytosis occurs very commonly in our body. Although you don't see, but leukocytosis occurs very often. When you get simple infection, like cold, okay, or any type of simple infection, the white blood cell count will go slightly up. So that is easy way to, sometimes you go to doctor and say, I got fever, okay? So if the doctor tests your blood, white blood cell count, and says slightly above 11,000, will think that you got infection somewhere in the body. Okay? So any kind of infection can cause leukocytosis, slight increase of white blood cells. And by looking at that, we can guess that the person might have some infection in the body. Penia means decreased count. So leukopenia is lower number of white blood cells, below 4,000. Okay. Now another condition, which is a serious clinical condition related to white blood cells, leukemia. I believe all of you have heard, right? Leukemia is also commonly known as blood cancer. That is an uncontrolled production of white blood cells. So the number of white blood cells goes up extremely high because of uncontrolled multiplication or production. Okay. Now, leukemia could be two types: myelocytic leukemia and lymphocytic leukemia. Now you see what happens when the white blood cells are produced. First, two types of stem cells are produced. One is called myeloid stem cell, another is called lymphoid stem cell. Okay? Differentiation, myeloid and lymphoid. Then from myeloid, we get 4 different types of white blood cells: eosinophil, basophil, neutrophil, monocyte. Only lymphocytes come from lymphoid stem cell. So if leukemia occurs due to lymphoid stem cell, then the number of lymphocytes will be extremely high. Makes sense? If that is due to myeloid stem cell abnormal multiplication, then other 4 types of white blood cells will be extremely high. So this is myelocytic leukemia, where 4 different types of white blood cells are involved. Lymphocytic leukemia, only lymphocytes. Now, what's the problem of leukemia? The white blood cells, those are produced, are mostly what? Non-functional. Although they are white blood cells, but they cannot function. They cannot destroy the microorganisms. Okay, that's the function of white blood cell, you know that. So these are non-functional white blood cells. So although the number is extremely high, but they cannot destroy the microorganisms. Make sense? They cannot fight. So the patient can get multiple infections, widespread multiple infections. And another is, since the white blood cell count increases a lot, blood becomes what? Viscosity? Thick. Viscosity increases. Make sense? So, when that blood will try to pass through narrow blood vessels or capillaries, because of that viscosity, pressure will rupture the capillaries or thin blood vessels. And that will cause widespread hemorrhage or bleeding in the tissue. So you will see internal hemorrhage due to the rupture of the capillaries or thin blood vessels. Make sense? So those two things we see in leukemia. Platelets are also called thrombocytes. Another name, thrombocytes. Platelets come from megakaryocyte. Now you see what happens. Hemocytoblasts produce the stem cell that will produce platelets. So this stem cell will produce a type of cell that is called mega means what? Big karyocyte. Now, megakaryocytes are big cells, okay? That's why called mega. And like this. This is a megakaryocyte, okay? Nucleus. What happens? Megakaryocyte, a tiny part of megakaryocyte with some cytoplasm and granules, no other organelles. Small amount of cytoplasm and some granules, they get detached from the megakaryocyte, detached from the main body. Make sense? And these are platelets. So, fragment of megakaryocytes. Make sense? Tiny piece gets off from the body. So now you tell me, these platelets have no nucleus, no organelles, right? Only cytoplasm and some granules inside it. So that's the platelet. So that's why some, I mentioned in last class, some physiologists, they don't want to consider these as cells because they are basically a tiny piece of the cell. But platelets are very important. For what? Blood clot formation, right? Blood clot formation, you know that. And that is now, see, I said that cytoplasm and some granules. And those granules contain serotonin, calcium ion, some enzymes, ADP and PDGF. Just know that among these, this one, ADP, so platelets, on the surface of platelets, you have ADP that comes out from the granules, and another thing that is called thromboxane A2. These two chemicals are very important because these two chemicals make the surface sticky. So what happens when you get a cut, the platelets get together, get attached to each other to plug, form a plug to seal the cut. So these two chemicals, just remember, are present in the platelets and they are helpful to form the clot. Here you see that hemocytoblast is the stem cell. Hemocytoblast is the stem cell, right? And that stem cell will produce the megakaryoblast, then promegakaryocyte, then megakaryocyte. So this is the megakaryocyte. I showed you megakaryocyte, and the wall, from the wall, tiny pieces get separated to form the platelet. So these are the steps how a megakaryocyte is formed. Okay. So don't have to remember everything. Just know that hemocytoblast is the stem cell for all blood cells, and for platelets, megakaryocyte is the cell that produces platelets. Okay. Okay. The last thing, hemostasis. Hemostasis is the arrest of bleeding, or haltage of bleeding, or stoppage of bleeding. So same thing, right? Arrest of bleeding or stoppage or haltage of bleeding. When we need it, when you get a cut, right? So you need it. You need hemostasis when you get a cut. Now, hemostasis has 3 steps. When you get a cut, those 3 things happen. You see here. This is a blood vessel. Okay. Now you got a cut here. So this is the cut. First thing, what happens? This is the normal size of the lumen, you know, the lumen of the blood vessel, right? Wide open now. So when you get a cut, immediately what happens? Constriction occurs. The lumen gets what? Smaller. Make sense? So that is called what? First step. Vascular spasm. See, this is the lumen. When you get a cut, squeezes. Okay, makes sense? So that will reduce the blood loss, right? When the lumen gets narrow, that will reduce the blood loss. So number 1. Number 2, I have just mentioned a few minutes ago, platelets can form plaque. Remember that? They get attached to each other because they are sticky. So what happens? The platelets will get attached to that area and form a plaque. Platelets love rough surface. Okay, so when you get a cut, that surface gets rough, right? So platelets love what? Rough surface. So will get attached to that surface, and that is called plaque. That will seal the opening. Make sense? And the last thing is coagulation. What will happen? How many of you remember 3 types of plasma proteins? Albumins, globulins, fibrinogens, right? Or fibrinogens. Remember I said? And I just told you 1 or 2 functions of each. So at that time I said fibrinogens to what? Blood clot. Remember that? So what happens now? The fibrinogens will form fibrin thread like this. That plasma protein will form net or mesh. We say fibrin mesh, and that will cover that plug to make it more strong. Okay, so fibrin mesh. That is coagulation. Okay, so that is coagulation. Fibrinogen forms fibrin net. That is called what? Coagulation. Is it clear? So those 3 things will happen to arrest the bleeding, to stop the bleeding. Okay. So let's stop here. We'll finish rest part in next class.